Hi guys, assalamu alaikum. Today we will solve a projectile motion question from the year May 2024. This is a projectile motion question which came in the year May 2024. Question number 17. So let's start solving. So they have said a child is playing a game. The child is trying to get stones to land outside an old tire floating on the water. So basically the thing is the child is just trying to get this ball onto this tire by launching it in the air. He wants it to land in between this tire which is flowing in the water. A child throws a stone at a speed of 6.3 and at an angle of 50 degrees to the horizontal. The speed was 6.3 meter per second at an angle of 55 degree. The stone leaves the child's height at a height of 1.5 meter above the surface of the water. So this height is 1.25 meter above the surface of the water to which it will fall. So in the question they have asked us So in this question they have said, show that the vertical component of the stone's initial velocity is about 5 meter and that the horizontal component is 4 meter. Okay, so basically they have asked us to find out the horizontal and vertical component of the stone which he is launching. Okay, so the thing is it was launched at 6.3 meter per second. So it will have it, as it was launched at an angle, it will definitely have a vertical component and a horizontal component. This is the horizontal component and this is the vertical component. So we all know as the horizontal component is within the angle, so it will be 6.3 into cos 55 degree, and as the vertical component is without the angle, it will be 6.3 into sin 55 degree. Sin comes when it is without the angle and cos comes when it is with the angle. So let's find out. 6.3 into sin 55 degree is equal to, this is for the vertical component, and for the horizontal component 6.3 into cos 55 degree. So the answers will be 5.16 ms minus 1 and it will be 3.61 ms minus 1. Actually it was a kid stuff, nothing else. Okay, so in question number B they have said, show that the greatest height above the surface of the water reached by the stone is about 3.5 meter. We all know as the stone is launched in the air, it will reach a height. After reaching that height, it will again come down. So they have asked us this maximum height which this ball will reach after it was launched from 1.25 meter above the surface of the water. So let's find out. We will use the formula v square equal to u square plus 2as in order to find out the greatest height. In order to find out this greatest height, we will use this formula, v square is equal to u square plus 2as. So we all know as the ball will reach its maximum height here and after then it will again come down. So here his velocity will be 0. His final velocity is going to be 0. And as the ball is moving in the vertical direction, as we are counting the vertical height, we will take the vertical velocity which we found out here, 5.16 ms minus 1. So the final velocity will be 0 and the initial velocity will be this velocity as it was the vertical component. As we are finding out the vertical height of the ball or the vertical height of the stone, so we will take this velocity, neither this 6.3 nor this 3.61. We just take the vertical velocity, which will be 5.16 ms minus 1 plus 2 into 9.81 into the s. As the ball is going upward and we are only concerned about the upward motion of the ball, we are taking the acceleration as positive. If we have taken the downward, if we considered downward motion of the ball, we have taken the acceleration minus g. When we take upward motion, we take positive g. And when the motion involves both positive and negative, both upward and downward, then we also take minus g. So this is a basic that I wanted to clear for you guys, that this is a really important thing, because a lot of students get stuck in these small basic problems which make them lose marks. Because if we have put here minus 9.81 other than the real 9.81, then we would have lost the mark and the whole math would have been wrong. We would have made problems in number C as well. So doing the right things right here is really important. So let's do it. So in order to find out the S, we have to do if we square this 5.16 centimeter square, which will be 26.6 m square s minus 2, divided by this 2 into 9.81 becomes 19.6. So the displacement is 13.6 meter, sorry 1.36 meter. It will be 1.36 meter above this height. It will be 1.36 meter above this height. This is the 1.36 meter. But we have been asked to find out the surface of the water, above the surface of the water. So we have to take this 1.25 into consideration as well. This is the height from which the ball was released or the ball was launched. But we have just found out the height of the ball after it was released from this 1.25 above the surface of the water. So we have to add this 1.25 as well. 1.36 plus 1.25 becomes 2.61 meter above the surface of the above the surface of the water. So let's move to the question number C right now, as we are already done with question number A and B. Let's move forward to the question number C. So the question number C, they have said us to find out. They have said what they have given us. The inside of the tire is 0.8 meter. Okay. So they have said the diameter of the tire, so is 39 meter from the side of the water. So the distance is given as 3.9 meter. This is the distance, which is 3.9 meter, and this is 0.8 meter. Okay. Deduce whether the stone thrown by the child land inside the tire. So they have asked us to find out whether this stone will land into this tire or it will fall short or it will go further away from the tire. So in order to find that thing, it's usual that we have to find out the horizontal displacement of the stone. If we find the horizontal displacement of the stone, then we will be able to easily be able to find out where it landed. If it is within 3.9 meter, then it will land here. If it is between 3.9 and 0.8, means if the horizontal displacement is within 4.7 meter, then it will land here. And if it is greater than 4.7 meter, then it will land here. And if it is less than 3.9 or equal to 3.9, it will land in here. So let's find the horizontal displacement of the ball. So to find out the horizontal displacement, we all know velocity is equal to displacement. Sorry, 1 minute. We all know velocity is equal to displacement divided by time. So here we have to find out the horizontal displacement. So we have the horizontal velocity, right, which we found out there. This was the horizontal component of the velocity, which was 3.16 meter. This is the 3.16 meter, which we will use right now because we are finding about the horizontal displacement. So we have the horizontal velocity, which is 3.61, and we have to find out this displacement, but we don't have this time. So in order to find out the horizontal displacement, now we have to find out the time taken for the motion. So let's find out the time taken for the motion right now, for the whole motion. So in order to find out the time of the whole motion, we know we will be following the formula V is equal to U plus AT. This is the formula we will use. So we all know that the initial velocity of the vertical component was 5.16 ms minus 1 into minus 9.81 into time. But we don't know the final velocity of the vertical component. We don't know the final velocity of the vertical motion. We know the initial velocity of the vertical motion, which we found out here, 5.16, but we don't know the we don't know the initial, we don't know the final velocity of the vertical component. So let's find out the final velocity of the vertical motion. So in order to find out the vertical motion, we can use v square equal to u square plus 2as. So here we can take v square equal to, we can root over this. We know the initial velocity, which was 5.16 squared plus 2 into, as we are taking right now the double motion, so the acceleration will be minus 9.81. Like I make you understand previously that when we take double motion, upward and downward motion, we take negative g. When we only take the upward motion, we take positive 9.81. When we only take negative, when we only take downward motion, we take minus 9.81. So here it is upward and also downward, so we have to take 2 into minus 9.81, and we all know the the displacement, which is minus 1.25 meter. Okay, so the answer of the velocity will be minus 7.15 ms minus 1. As we right now know the final velocity minus 7.15, now we can put this right here. Minus 7.15. So right now we can find out the time, which will be minus 7.15 divided by the time will be 1.25 seconds. So this is the time for the whole motion. So now we know the time, we have to just find out the displacement. So we can plot as divided by 1.25 seconds. which will be multiplied here, and then we will be able to find out the displacement, which will be 3.61 into 1.25. The answer will be 4.51. So as we all know, the horizontal displacement of this position is 3.9 meter, and here is 0.8. So for the ball to reach this tire, it has to be greater than 3.9 meter and less than 3.9 plus 0.8, which will be 4.7 meter. So it has to be between 3.9 and 4.7. As it is 4.51, so it is between that displacement period. So the ball lands in the tire. You can write it here that 3.9 is greater than stone is greater than 3.9 and less than 4.7. So the ball lands in the tire. Hopefully you guys understood this math. So another thing that I want to announce is that we are starting question paper solving lecture videos, a question paper solving course for the October 2024 candidates, and a crash course for January 2025 candidates, where we will revise the syllabus and thoroughly solve all the recent question papers from January 2020 to May 2024. So if you guys want to ameliorate your marks just before the exam and excel in the exam, kindly do message us in our Facebook page, Edexcel Exam Essential. You can have a free demo class with us, where we will let you know the way we will move forward to get a better result and bring out the best out of you guys. And you can also do a demo class under me, where I will solve a question paper for you. So if you want to join me, then let me know in the comment section, or you can message me in my Facebook page, Edexcel Exam Essential. Have a good day, guys. Bye bye.